Hello, grade 7. Hope you're doing great and staying safe at home. Today's topic is in section 2, chapter 14, page 258 about electric current and electrical energy. So we are starting this subject today. So electric current, first we have to know the definition and what is electric current. Electric current is the rate at which charges pass through a given point measured in ampere. Maybe you hear that your dad said, oh, we have 5 amperes, so we cannot turn on many things. Okay, what does this ampere means? Means how many charges is passing through the wires inside your home. So if the charges are more than the rate which the wire is holding, so you cannot have the electricity. But if it is less than that one, so you can have electricity. So the rate at which charges pass through a given point measured in amperes, we have two types of electric current, AC and DC. Maybe you hear this one. So AC is like the governmental electricity which we have. It is AC, has only one direction and it is very dangerous. You cannot touch it. And DC changes its direction and it is not damage, danger. It is like in electricity of the small batteries. They are only 7 or 5 volts. It is easy and it is not damage, danger to touch, but be safe and don't touch it, okay? So voltage. Danger, high voltage, electrical shock hazard. Maybe you saw this one in many places, especially in the hospital, the X-ray or the MRI room. They hang this attention and you have to take care because voltage is the potential difference between 2 points measured in volt. Okay, in our country we are using in our electricity 220 or 240 volts. If the volt is more than that one, our devices, our electrical devices is not working, like your PC, your phone are extra. But if it is less than one as well, it is not working. And voltage is very dangerous. Anything has a high voltage, it is having shock hazard and it is not that much safe. You have to be far from it. Resistance. Okay, what is resistance? Resistance is the opposition presented to the current by a material or device. Okay, we have 3 factors of resistance: length, thickness, and temperature. Resistance is this picture, maybe you have seen inside the electrical devices. Resistance is letting the charges to go easily or to not easily. How's this one? So if a wire is thin, like picture number 1, or if a wire is thick, like wire number 2. So thicker wire has lower resistance. So the thicker wire has lower resistance and the charges can go through it easily. But the first one, which is thinner wire, has more resistance and the charges cannot go easily. So it is not suitable for the electricity to use. Second factor is length. So wire S and wire T, longer wire has higher resistance. So this one, number 2 as well, and number 1, okay. Wire number 2, because it's longer, so it has more resistance and it is not suitable. So, but wire number 1 has short length and it is good to transforming charges. Electrical energy. So it is very easy and you have to understand that we have two kinds of cell, dry cell and wet cell. What are they? Dry cell is like this one, this small batteries. Okay, if you look here, it is written 1.5 volt. Okay, 1.5 volt. We understand what is volt before. Okay, this is dry cell and it has DC electricity. But wet cell, like the car battery has more voltage and more ampere than these small batteries. Okay, we have to take care and we cannot touch this one, and it is danger. Okay, you have to understand the kinds of cell we have: fast dry cell and wet cell. And at the end, your homework is take pictures of kinds of cell. We said we have two kinds, dry cell and wet cell. Search online, Google it. You can understand what are more examples about dry cell and wet cell in electrical current, and take pictures of kinds of cell and send the pictures to us. Goodbye.